Hi again. Okay, so this time we're going to be talking about the marginal rate of substitution and adding just a touch of calculus. So that Marginal Revolution University video ended with this magical concept that the consumer chooses optimally. They make the best choice when they choose the point of tangency between the budget constraint and the indifference curve, right? That point of tangency. And at that point, the price ratio is equal to the marginal rate of substitution, because the slope of the budget constraint is the price ratio and the slope of the indifference curve is the marginal rate of substitution. But that's sort of where they left it, and that's because they assume that you don't know any calculus. I know better. I know that you know some calculus, so we can go a little bit further. And more specifically, we can calculate what exactly is that marginal rate of substitution mathematically, what is it, and then we can actually use it to solve some problems. So this is the first video in a 2-video series where we're going to talk about the MRS right now, and in the next video, I'll show you how to actually use it to solve some problems. Okay, so first we need to step back and remind ourselves, what is a utility function? A utility function is just an economist's way of relating how much of something is happening in your life to how happy you are. Oftentimes we talk about goods and services, stuff, but we could put anything we wanted to in that utility function. And indeed, economists often think about things that are not goods and services, like leisure time, for example. Labor economists think about how people make trade-offs between how many hours they spend working, and therefore how much money they get, and so therefore how much stuff they can buy, and how much they value taking time off. That balance between labor and leisure is what labor economics is all about. Anyway, so that utility function, all it is, it's a mathematical relationship between how much of something is happening in your life and how happy you are. So for example, let's think about media consumption. We can think of T as the number of movies that are consumed in a theater, and N as the number of movies that are consumed on Netflix at home. And this here shows the mathematical relationship between T and N and utility. So it says that utility is a function of T and N, and specifically it is T to the 0.5 times N to the 0.25. All right, sweet. So then in the Marginal Revolution videos, they also showed you what's called an indifference mapping, right? An indifference mapping. And all this shows is the number, all of the points, all of the combinations of movies watched on Netflix and movies watched in the movie theater that give a person a utility level of 5. Whereas this indifference curve shows all of the combinations of movies in the theater and movies on Netflix that give you a utility level of 7. And this one shows all of the combinations of movies in the theater and on Netflix that give you a utility level of 10. Okay, so that was those indifference curves. And then what they ended with was that the marginal rate of substitution is equal to the slope of that line. And just as a reminder, the slope is the rise over run. The rise, the change in the number of Netflix movies watched, by the run, the change in the number of movies watched in the theater. Okay, but what exactly are those indifference curves? I want to try to do some fancy graphing to give you a better sense of what that is. Okay, so here is that same indifference curve, right? So this set of points here shows all of the combinations of movies watched in the theater, that's on the x-axis, and on Netflix, that's on the y-axis, all of the combination of points that gives the person a utility level of 5. And I can turn on a layer for 7, and I can turn on a layer for 10. And those are just indifference curves. That's looking at it from above, okay? And now I want to change it around, because all those indifference curves is slices of a 3-dimensional object. So now I have that same function. So I've got theater on the x-axis, Netflix on the y-axis, and utility on the z-axis. Utility is height. Now, this will be familiar to a lot of you because we live in Colorado and we see this all the time. All those indifference curves is slices of a 3D object. They are lines on a topographical map. Yeah, it's a topo. Indifference curve mapping is a topo. That's all it is. Awesome, huh? Okay, so that's cool. So now you can see what that object looks like mathematically, and you can see that those indifference curves are just looking at it from the top with different slices of levels of utility. I want to show it to you, that same object, from a different perspective. So I'm going to turn off my indifference curve slices, and I'm going to rotate it. So right now on my x-axis I have movies seen in the theater, and on my y-axis I have movies seen on Netflix, and you can't really see the utility axis because I'm looking at it from above. So now I'm going to tip it to look at it from the side. So now I'm showing the x-axis and the z-axis. So I've got theater movies seen in the theater here, and movies and utility here on my z-axis. Now I'm going to turn on another slice. This is taking a slice through it sideways. So it's fixing the number of Netflix movies watched at 5. Now, why you'd ever want to restrict yourself to only 5 movies on Netflix is beyond me, but whatever. Suppose you did. There's fixed at 5. And so what you can see there is a utility function that is slowly increasing. So let's go back to the PowerPoint slides and look at that. Okay, so this is the utility function looking at holding the number of Netflix movies constant at 5. All right, what I want you to see from this is this helps us to start thinking about the concept of marginal utility. So if I watch 0 movies in the theater, my utility level is 0. And if I increase the number of movies watched in the movie theater to 5, my utility increases to here, because I like going to the movie theater. Great. Now, what if I increase from going from 5 movies in the movie theater to 10 movies in the movie theater? Well, what you can see there is that your utility is still increasing. I still enjoy going to watch movies in the movie theater, but it increases less for the second 5 movies in the movie theater than for the first 5 movies in the movie theater. Which makes sense, right? Because when you don't go to the theater at all, the first 5 movies are really exciting. But once you've already been to 5 movies in the movie theater in a month, how much can the extra 5 actually, how much extra happiness can it bring you? Less. And similarly, if we look at the difference in utility of going from 10 to 15, it's even less still, because 15 movies in the movie theater? Seriously? Who has time for that? So what this shows is what's called the concept of diminishing marginal utility. Diminishing marginal utility. And all that means is that your increase in utility is still constant as you consume more and more stuff, but it gets less and less valuable the more of it that you have already. Okay, marginal utility is the additional happiness a person receives from consuming just one additional unit of whatever it is you're talking about. Cool. So let's do an example. How do I actually calculate a marginal utility? Well, there's my utility function u. And remember, the concept of marginal utility is hold one variable fixed and then tell me how utility changes as the other variable increases. Well, hey, that's just a partial derivative. You did watch the video on partial derivatives, didn't you? Didn't you? Go watch the movie. All marginal utility is just a partial derivative. And if you watch the movie on partial derivatives, you'll remember that the key there is to just treat the other variable like it's a constant. It's just a number. So if I take the partial derivative with respect to t, all I do is I move that 0.5 down front, I subtract 1 from the exponent, and I leave the n alone because it's just a constant. Leave it alone. All right, that's marginal utility. Great. Now, how is that related to the marginal rate of substitution? That's where we're going next. And here's the punchline. The marginal rate of substitution is equal to the ratio between the marginal utilities. How? Why? Prove it to me. That's what we're doing. Okay, so suppose that this month you plan to go out to the theater twice, and you plan to stay in and watch Netflix 4 times. All right, so I'm just going to pop in 2 in for my going out to movies in the theater, and 4 of going out to movies, staying home and watching movies on Netflix. That's cool. But now, suppose that a friend invited you to go out for an additional movie in the theater, right? So the change in the number of movies that you see in the theater would be 1, because you would go out to see 1 additional movie. How would that change your utility? Here's where we can use the concept of marginal utility, because marginal utility, remember, just tells you how much utility increases when you increase the variable by 1 unit. And so if you multiply that marginal utility by the size change that you're thinking about doing, that will tell you how much your utility increases, right? And so if I pop that 1 in here, that's the proposed change in the amount of movies that you would watch, and this is the marginal utility of where you're starting at, 2 movies in the theater and 4 movies at home, and that is the change in your utility because of the change of movies in the movie theater. Now, people who are watching closely will notice that I do have this squiggly equal sign right there, meaning approximately. Why is it just approximately? Well, you have to remember that calculus is based on the idea of infinitesimally small changes. And here we're talking about changing the number of movies that you go see by a whole unit. That, technically speaking, breaks the calculus, but trust me, we can play fast and loose on this particular point. Anyway, okay, so, but now your friend invited you to go out to the movie at the theater, and you might be thinking about then adjusting the number of movies you watch at home on Netflix. How would that change your utility? Exactly analogously, it's just the number of movies that you watch less at home on Netflix times the marginal utility of watching a movie on Netflix. So what's the total effect on utility? Well, the total change in utility, du, is equal to the change that comes from the number of movies that you increase watching in the theater, and also the change that comes from watching fewer movies on Netflix. Almost there. Remember, however, along an indifference curve, the whole point of an indifference curve is that utility is constant. Along one line on the topo map, your height, your elevation is constant. That's the whole point of a topo map. So, along an indifference curve, the change in utility is 0. Yeah, along an indifference curve, the total change is 0. So let's see if we can rearrange that to get to our punchline. First thing I'm going to do is I'm going to move this over to the other side. Next thing I'm going to do is I'm going to divide both sides by dt. So I end up with dt in the denominator over here. And then I'm going to divide both sides by the marginal utility of n to get that on the denominator over there. And then I'm going to move the negative sign over here. And lo and behold, what did I get to? The slope of the indifference curve is equal to the ratio of the marginal utilities. That's the marginal rate of substitution. Huh. All right, let's do an example problem. So suppose you have a utility function of x and y, x to the a, y to the b. What is the marginal rate of substitution for this utility function? Well, first thing I have to do is I have to do marginal utility of x. And remember, when I take the partial derivative of that function with respect to x, I just treat y like it's a constant. And so the marginal utility of x is a to the x, a minus 1 times y to the b, because I just leave that y alone because it's just a constant. Now I take the marginal utility with respect to y, and from that perspective, from that partial derivative, I treat x like it's a constant. So I just leave it alone, and I take the partial with respect to y, and I get b, y to the b minus 1. My marginal rate of substitution is just the ratio of those two things. So I'm going to divide the one by the other, and I get my MRS equals, so let's say I have an a on top, and I have a b on bottom. Now, what am I going to do with those x's? Let's see, I have an x to the a in the denominator, and I have an x to the a minus 1 in the numerator. So I can cross out this xa, and I can cross this a out of the exponent. And similarly with the yb, I have a yb on top, and I have a yb minus 1 on the bottom, so I can cancel out that b in the exponent. Now, I have an x to the negative 1 in the numerator. That's like saying 1 over x in the numerator, so I'm just going to put the x in the denominator. Similarly, on the bottom, I have y to the minus 1, so that's like 1 over y. So I'm just going to, 1 over y in the denominator. I'm going to put the y up top. And there you go. The MRS is a over b times y over x. Fantastic! So that's the end of this video. In the next video, we're going to actually use this ratio between the marginal rate of substitution and the price ratio to actually solve a problem. See you later.